So hello everyone, let's solve today's GfG problem of the day. The problem name is minimum cost path. So let us read the problem statement. So given a square grid of size n, each cell of which contains an integer cost that represents the cost to traverse through that cell. We need to find a path from top left cell to bottom right cell given by which the total cost incurred should be minimum. And from a particular cell we can go into 4 directions, that is up, right, left and downwards. So these are the 4 directions in which we can go. So what we need to do, we need to traverse from top left cell and we need to reach to the bottom right cell such that the path that we choose, that path's cost should be as minimum as possible. So let us see this first example and try to find some solution out of it. So this is the first example that they have given, and what the question is saying that from this top left corner we need to find the minimum distance to reach bottom right corner. Now there can be many possible paths, like this can be one possible path, this can be one possible path, so there can be many possible paths. So we need to find path which has minimum cost. Now how will we find the cost? This cost is nothing but the value that is present in the path. So for example, for this path the cost will be 9 plus 4 plus 7 plus 6 plus 3 plus 7 plus 10. So this will be one cost. So in such a way that we need to find minimum cost to reach from top left cell to bottom right cell. So this is what the question is saying. So we have this term in this question, that is minimum cost. So if we have this term minimum, what is the first thing that we can think of? We will think of greedy approach. But greedy will fail here, because if we are standing at some particular node, let's say I am standing at this 7. So what all possible directions I can go? I can go to up towards 4, right I can go to 6, down I can go to 3, and left I can go to 6. Now I'll pick minimum amongst all the 4 directions. So 4 is the minimum. So you might think that yeah, I can follow this path, but this path doesn't guarantee the minimum, because currently I have the minimum cost. This is for the minimum amongst all 4, but that doesn't guarantee that the path that this will choose which will give us the minimum or not, because in this path all the values can be very large. So that doesn't guarantee that we will get the minimum cost or not. So greedy will fail here. So you might think that greedy is failing, so we need to find all possible options. So we will use DP memoization. But here in this question DP will also not work. Now why DP will not work? In the previous questions of DP in which greedy was failing, there was one thing to notice. We were only going in the forward direction. By forward direction I mean either to the right side or to the downside. But in this question we are going backwards also, like towards the left side and towards the upward direction. So here we need to take care of both of these things, by going forward as well and by going backward as well. And we can't do this with the help of DP. Like there might be some scenario we might get into, like we might stuck in some loop as well, because we might visit some node again and again. And even if you think we can maintain a visited array, it will still not work, because we can't handle this backward direction and forward direction both with the help of DP. So DP will also not work in this case. So what we will do? So we need to find some algorithm which is efficient and which can solve our problem here also. So if you know one thing, we can relate this problem with Dijkstra algorithm. Now how we can relate this, let me show you. Now what was the main criteria for Dijkstra algorithm? So let me just show you. So Dijkstra algorithm is prerequisite for this problem. I'll not explain the Dijkstra algorithm because then video will be very long. So Dijkstra algorithm is prerequisite. So what was the main criteria of Dijkstra algorithm? A single point source, as well as it will find minimum distance from this single point source to all other nodes, and the distance will be minimum. from source to all the other nodes, the Dijkstra algorithm will find the minimum cost. So this was the criteria of the Dijkstra algorithm. Now how we can relate here in this question? Now if you observe carefully, what is our source here? Our source is top left. Now this top left will be fixed in each and every question. This top left will be this starting node only. So we can say that this is a kind of single point source. Yeah. And now from single point source we can obviously find minimum distance to all other nodes by going to each and every node with the help of priority queue and all that. With the help of Dijkstra we can do that. So yeah, we can relate this question with the help of Dijkstra algorithm. So how will we find the minimum cost from point source, like from the top left to bottom right? Now what was the second criteria? Single point source to all other nodes. So from single point source I will reach 4, I will reach 9, I will reach 9, I will reach 7, I will reach 6, I will reach 6, I will reach 4, again I will reach 8, I will reach 3, I will reach 3, I will reach 7. Now again here also I will reach 7, I will reach 4, I will reach 9, and in the end I will reach 10. So from this single point source I am going to all other nodes to find the minimum distance from that source to particular node. Now if I am trying to traverse to all other nodes, then this node will also be coming into our picture. And what is this node? This node is nothing but the destination or endpoint. So endpoint is bottom right. So from single point source we are reaching to the bottom right, and we are getting the minimum cost to reach that bottom right coordinate from this top left coordinate. And this is what we need to find. So with the help of Dijkstra algorithm we will apply that Dijkstra algorithm in this question, and like from top left corner we will find the minimum cost to reach bottom right corner. So this is how we'll apply the Dijkstra algorithm in this question. So let us see the code now and understand in more better way. So let us write the code now. So first I'll declare integer n and m. N and m is nothing but the row and column size of our grid. M equal to grid of 0 dot size. Now we need to traverse in 4 directions. So let me define 2 vectors which will be helpful in traversing in the 4 directions. To dir of x 4. So this is a trick that we use in Dijkstra algorithm or BFS code. So 0, 0, 1, -1. So this is for direction for traversing in the x. Similarly we will create for y, dir of y, which will be of size 4, and yeah, first will be -1, then 1, then 0, 0. So these two arrays will help us in traversing in the all 4 directions. Now we need to define priority queue, because in Dijkstra we use min heap. So int vector of int greater int priority queue. Now here we are not dealing with the integers. What we are dealing with? We are dealing with cost, we are dealing with x coordinate, we are dealing with y coordinate. So we are taking care of 3 values. So what we can do? We can create a pair of integer pair of integer integer. So this is what we'll create. So how it will store value? It will first store cost, then it will store the x coordinate, y coordinate, and yeah, this is how our pair will look like. So instead of integer we will store pair of int pair of int int. So let me just replace this integer with this value. So yeah, instead of integer pair, and again in the instead of integer pair. So yeah, so we have declared our priority queue. Now what we need to do? First we need to push the single point source, that is the top left corner, into our priority queue. So pq.push. So first what will be the value? First will be the cost. Now what is cost? Cost is nothing but the grid's value. Grid of 0, 0, comma, what is the coordinate of the top left? It will be always 0, 0. So this will be pushed in our priority queue. Now what we need to do? We'll apply Dijkstra algorithm until our priority queue doesn't become empty. Now before that, we need to also create two vectors, that is visited and distance vector. Visited vector will take care that we are not visiting each node again and again, and distance vector is obviously will give the minimum distance from point source to that particular node. So vector of int, so visited will be of same size n comma vector of int m, and initially we are not visiting anything, so it will be 0. Distance, so distance will be vector of int, and we'll name it as dis. It will be of same size n comma m, so vector of int of m. Now initially, now we need to find the minimum distance, so we will initialize this distance vector will be the maximum value with the maximum value. So we can take any large value that will not hamper our case. So I'll take it 1e9. So we have initialized visited vector and distance vector as well. So now we need to apply our Dijkstra algorithm. So first we will pop the topmost element. So that topmost element will be of pair of int comma pair of int comma int. So let me declare that again, int comma int. So let me name that topmost element as node, so pq.top, and then we will pop that topmost element from our priority queue. Now this one have the cost as node.first. The first element of the node, or the first in this integer value will be the cost, will correspond to the cost. This integer value, that is, will correspond to the x coordinate, and this will correspond to the y coordinate. So cost equal to node.first, x coordinate will be equal to node.second.first, and y coordinate will be node.second.second. So yeah, we have found out x coordinate, y coordinate, and cost. Now we are trying to visit this node by going to its adjacent elements in the 4 direction. So we need to first mark this as visited. So visited of x comma y equal to 1. Now also we need to take care one thing before that. If this node was already visited, so if visited of x comma y was 1, then we need to not check this because we have already find out the minimum. So just continue, we will not consider this case. Now there can be one more possibility. If this x is equal to n minus 1 as well as y equal to m minus 1, that is, we reach the bottom right coordinate. And if we reach the bottom right coordinate, that distance we get, or that cost we get, is the minimum cost, because if we are popping that top element out of our priority queue, and the priority queue is min heap, and if we are popping this element out, so obviously this cost will be the minimum cost, and the coordinate is n minus 1 and m minus 1. So we reach the bottom right coordinate with the minimum cost. So this will be the minimum cost that we have till now. So we will simply return the cost. So this is the thing that we need to take care of. Now what we need to do, we need to check in all 4 directions. So for checking all 4 directions, we will take help of these 2 arrays. So we will iterate in 4 directions. So from 0 till I less than 4, I plus plus. Sorry for that. Yeah. So what we need to do, we can go to upward direction, downward direction, right direction, and left direction. So we will define new coordinates. So new x and int new y. So yeah. So what will be this new x? Current x plus dir of x of I. And what will be this new y? Y plus dir y of I. Now we need to check if these new coordinates are within our range or not, and if we have already visited or not. So we will check if this is in if these are not out of bounds. So for that we can say that if this new x is less than n and this new y is less than m, as well as they are also not negative. So if this new x is greater than equal to 0 and new y is greater than equal to 0, as well as these are should not be visited. So not visited of new x comma new y. So if these things follow, that means we are within our bounds and we have not visited this element till now, so we need to visit this. So what we will do, we will first check its distance. So if its current distance, so what will be its current distance? Distance of new x comma new y. So if this distance is greater than what we will find the new distance. So what will be the new distance? Grid of new x comma new y plus whatever we have distance till now. So distance of dis of x comma y. So the current distance is greater than what we are finding now. That means we find a new minimum distance. So we'll update that distance with the new minimum distance. So we'll update this distance with this new minimum distance. Control C and Control V. So yeah, as well as we will push it into our priority queue. So pq dot push. So what we will push? The new distance. What is the new distance? New distance is this. So this one, as well as what are the coordinates? Coordinates are new x comma new y, and yeah, this is how we'll push it into our queue, priority queue. So this will keep on happening until our priority queue becomes empty, or we hit this condition where we reach the bottom right cell. Now if we didn't reach the bottom right cell, that means like we can't reach it, but this won't happen, but still we need to return something. So we'll return -1 here. So this is how we have written our code. So let us see if this works fine on cases and gets accepted or not. So it is giving us the error. So yeah, we have written the wrong spelling of our distance vector. Let's see if this works fine or not. So it is giving us the wrong answer. So we forgot one thing here, that when we are initializing the distance vector, so we have set all values to 1e9, but the distance from source to source will obviously be the top left value itself. So we need to change that. So distance of 0, 0 will be equal to grid of 0, 0. So this was one change that we need to make. That's why it was giving us the wrong answer. So now let us check if it gets accepted or not. So yeah, our code got accepted. So hope you learned from this video. Thank you.